everyone, we're going to find the limit as x approaches 1 for x cubed times f of 1 minus f of x squared divided by x minus 1. And this is when f of 1 equals 1 and f prime of 1 equals 2. So basically what we're doing is looking at this formula here to help us solve this or find the limit. We have f prime of 1 equals 2. So our a is 1 because it's f prime of 1. So that equals your a, which equals 1. This problem is a bit confusing because it doesn't actually fit our mold very well. So let's start working on it. We're going to do the limit as x approaches 1. That's your a. Now, we don't have a f of x. We have this x cubed. So basically, instead of f of x, you're just going to write x cubed minus f of a, which for us is f of 1. And then we have this f of 1 here. So you're just going to multiply all that by f of 1. Remember, f of 1 is just 1. So if you wanted to, you could just call it 1 at this point. Now we have this second part. So that part, we just repeat what we just did. But in that terms, it is f of 2. So it's going to be minus f of x squared minus f of 1. Okay, so this one fits our mold better. And then our x, we're just going to put x minus 1. All right, because this is like your x minus your a. All right, and this is x minus 1 as well. All right, now f of 1 is just 1, so I'm going to put a 1 there. This is just going to be 1, so let's go ahead and put the 1 there. Now I'm going to expand this. This is going to be the limit as x approaches 1 of x. I'm using this formula here, right here. So that's going to be x minus 1 times x squared plus x plus 1, all divided by x minus 1. So what happens here, this goes away. So this one's actually treated a lot differently than what we're doing this one. Now this one, I'm going to go ahead and write this as minus, let's see what I can do here. F of x of 2, x squared minus f of 1 divided by, I need to match these up. These x's have to be matched up. I have an x squared here, and I just have an x here. So I need it to be x squared. So what I can do is multiply my numerator and my denominator by x plus 1. Now if I do that, what's going to happen is you're going to have the limit as x approaches 1. This is going to be x squared plus x plus 1. All right. And then for this piece, when you multiply these two, you're just going to get minus f of x squared minus f of 1 divided by x squared minus 1. Now these two match, but we still have this x plus 1 in the numerator. All right. Now let's fix this side up. We've got this done. So we're going to fix this up. I have f, the limit, as x approaches 1 of x squared plus x plus 1. And again, this was times f of 1, which is just 1. I'll just put f of 1 now. All right, minus f of x squared minus f of 1 divided by x squared minus 1 times x plus 1. All right. From here, we're going to write this as 3. If you substitute in your 1, you're going to get 3 times f of 1 minus, now this part matches our derivative here. So I know that this is f prime of 1. Okay, because that's your 1. We got it to match up. And then we still have this x plus 1. So that's going to be, when you substitute in 1, you get 1 plus 1. This is going to be times 2. So this is going to be 3 times 1 minus f prime of 1 is 2. So you have 2 times 2. This is going to give you 3 minus 4, which equals negative 1. This one was really confusing. All right, that's it. Thank you. Have a nice day. Bye-bye.